All right, guys, welcome to Unit 1, Day 4-ish, okay? Today is going to be a little bit of a two-parter, so hang on with me. To begin today's lesson, did you all know that you are stars? And I don't mean this kind of star, right? Because y'all probably already know that you're stars in my mind, but I'm actually talking about these kinds. Right, the stars that are in the sky that you see at night, okay? And each one of you are all stars. And we're going to look exactly about how that happens. So today's objectives that we are going to hit is 1, you can identify the 3 types of nuclear reactions that occur. We're going to compare and contrast nuclear fission and fusion. And you're going to compare the relative amounts of energies released from these nuclear reactions and compare them to regular chemical reactions that occur. To begin us off, okay, nuclear reactions are the breaking and the building of elements, okay? So under extreme conditions, the nuclei of your atom, okay, can be combined or they could split apart, okay? Atoms that are small are combined in the stars. Atoms that are larger than iron, so if you find Fe, element number 26 on your periodic table, all of the elements that are larger than that are created when dying stars explode, okay? And the largest elements on Earth are made in labs, so they actually don't naturally occur. However, they are made by scientists. And all of our elements that exist on the periodic table are created through nuclear reactions, okay? When we say nuclear, what comes to mind? Okay. Whatever the term nuclear means to you, whenever we use it, it merely refers to the nucleus, in this case for chemistry, or the center of everything, right? We learned about biology, the nucleus of the cell, right? It's the center, everything revolves around it, okay? So nuclear reactions, as I said, deal with the nucleus, okay? And under these extreme conditions, whether it's heat or pressure, okay, the nucleus of these atoms are either combined or split apart. And so whenever we have a new nuclei, we have new elements because we know that the minute we change the atomic number, right, the number of protons that are in the nucleus, we get a brand new element. And there's 3 ways that our atoms can be changed from one type of element to the other. And our 3 types are nuclear fusion, nuclear fission, and nuclear decay. In this video, we're going to be talking about the first 2, and then in the next video you watch, we're going to be talking about the third one of nuclear decay. So let's start first with fusion. Okay, when you think of the word fusion or the verb to fuse, what do you think about? Right? When you're fusing something together, you're combining it. So that is all nuclear fission is, or fusion, my apologies, nuclear fusion is, okay? You're combining nuclei, okay? So you're gonna take light, small nuclei, and under massive heat and pressure, right, those external extreme conditions, you are gonna be fusing those 2 or 3 smaller nuclei together, and you're going to produce a heavier, larger nucleus. Okay? In the diagram on this slide, you can see that helium-4, right, meaning my mass number is 4, is made through 2 types of hydrogen nuclei coming together and fusing to give off helium and then this spare neutron here. So a neutron exists on its own. You also see that a lot of energy is produced, and we're going to look at that in a moment, okay? That diagram that was just shown is a major fusion reaction, right? We have hydrogen plus hydrogen gives us helium. This is how we can write a neutron, right? Because there's no protons, and my mass number would be 1, and energy. Okay. And this fusion reaction is actually how the sun is formed, right? And the sun is just a giant star, so this is also how our stars are formed. Okay, so the stars in the sun are made through fusion reactions. Okay, and fusion reactions release extreme amounts of energy, right? Think, how can the sun, which is millions and trillions of miles away, give us heat and light all the way to Earth, right? The only way that it can do that is through the enormous amount of energy that it can be producing, okay? Nuclear fusion, right, has been a topic of being able to produce energy here on Earth, right? And the biggest pros that it has, right, is that it can be the holy grail of clean energy, okay? We get an abundant supply of energy worldwide. It's environmentally clean. It does not create weapon materials. There's no runaway reactions, okay, meaning that my reaction gets out of hand and can potentially be dangerous, leading to accidents. However, the biggest con is we have not been able to produce a nuclear fusion reaction on Earth yet. Who knows, maybe you guys will be the next generation of scientists that can do this, okay? But nuclear fusion gives off the greatest amount of energy known to man as of right now, okay? And that is how all of our stars are formed, okay? The next type of nuclear reaction is nuclear fission, okay? Nuclear fission is pretty much the opposite of nuclear fusion, right? So I want you guys to imagine you guys are playing a game of pool, okay? You see my lovely pool balls being racked here. And I want you to think about what's going to happen when the cue ball hits all of your other pool balls, right? When the cue ball hits the other balls, right, they're going to fly in different directions. This is essentially what's going to happen in nuclear fission, okay? The wrecked balls represent the atom's nucleus, and the cue ball is what we call a neutron bullet, okay? In this diagram, you see this reaction occurring, right? The neutron bullet, right, my cue ball, hits all my other balls, right, which is going to be my atom nucleus. In this case, it's uranium, okay? And that's going to cause a split, right, to produce two new atoms, okay? Again, it's producing a lot of energy and giving off neutrons, right? So fission, unlike fusion, right, takes a heavy, large nucleus and splits it into smaller, lighter nuclei. Okay, so it's pretty much the exact opposite of fusion, okay? And as we said before, okay, this is how, okay, all of our elements larger than iron are created, okay? This is what happens in exploding stars, okay? As we said in the beginning, right, y'all are stars. It's because of nuclear reactions and the breaking apart or formation of, okay, new nuclei that create our new elements. So your body and you yourself are made up of all different types of elements in our universe, right? And that only came from the formation and breaking apart of stars. So you are physically made of stars or star dust, okay? Nuclear fission undergoes its change either spontaneously or can be induced, meaning some elements fission occurs regardless, right? It's just going to happen. However, sometimes it needs an extra push, and you saw that with this, right? This extra push, okay, of this neutron is bombarded, means it's with a lot of energy forced into uranium. Okay? And that makes my chemical reaction, or I should say my nuclear reaction, occur. Induced fission reactions only occur in labs, okay? We only do them in scientific labs. And nuclear fission is responsible for a lot of energy as well. Not as much as fusion, okay? Fusion is the greatest amount of energy that we have, okay? But fission creates a lot of energy as well. And the best examples we have of the amount of energy that it can give off is through nuclear weapons and nuclear energy. Okay. You may be familiar with some nuclear weapons, okay? They rely on uranium and plutonium, okay? So when the nucleus of uranium-235 splits, right? We saw that in the diagram. 2 isotopes are formed and a bunch of neutrons are given off or emitted, okay? Those neutrons that are given off then collide with other uranium-235 atoms, causing them to undergo fission, then releasing neutrons, and so on and so forth, right? This causes a chain reaction. This is exactly how the atomic bomb works, right? So way back in World War II, you guys have probably all heard about the ending of World War II with the bombings on Japan. This is what caused it, right? We use nuclear fission, okay, in the atomic bomb that we dropped on Hiroshima and Nagasaki, okay? And that caused a massive, right, explosion, giving off a bunch of energy because of the fission of uranium, okay? The other type of nuclear fission that we have seen in today's world is nuclear reactors. Okay, you guys may or may not have heard about the disaster at Chernobyl if you haven't seen that series on HBO and are over the age of 17 because it is a MA rated show. Go check it out. Okay, but nuclear reactors occur all over the world. Okay. And it produces nuclear energy that relies on uranium and thorium. And it happens because, okay, fission heats up water. Okay, so fission happens, it gives off a lot of energy, and that energy heats water in a vessel. And then that vessel, okay, so this is the vessel here, carries the heat away, okay, which then heats up water in a second system, turning it to steam. That steam then turns this turbine that produces electricity in a generator, and that is able to give us electricity and give us energy, okay? The biggest problem with this is it can be unstable, which we've seen in nuclear reactor disasters, okay? This is the best picture that I can show you. This is Chernobyl when the nuclear reactor blew up, okay? Now, currently in Ukraine, people can still not live in that area because there is a lot of radioactive pollutants, okay, covering a lot of miles, okay? It's very, very dangerous, caused a lot of issues, okay? People claim that the biggest pros to nuclear fission, okay, being their reactors, is that it has no air pollution, okay, if done properly, okay? If it stays in the reactor itself, there's no air pollution, and an enormous amount of energy is released comparatively to fossil fuels, okay? And it's an alternative to using our rapidly decreasing fossil fuels on Earth, right? So our fossil fuels are decreasing here on our planet, and so people are saying that we can use fission in nuclear reactors to be able to produce energy. However, we also know that it can go wrong, okay? When it goes wrong, it creates a lot of air pollution, okay? Creates a lot of destruction. It causes birth defects, okay? We also have no solution for our waste products, meaning that if we have to use some sort of container, okay, those are radioactive and can erode or break, okay? There's thermal pollution, which means that the heated water that we use is returned to rivers, which can then cause problems. And there is also a potential theft of fuel that we use in nuclear weapons, okay? Because nuclear weapons are highly sought after by countries because it is a very powerful device, okay? There's a lot of potential theft, okay? So this is our introduction to nuclear fission and fusion, all right? So you can finish up this video. Once you feel like your notes are good to go, you can stop this and go on to radioactive decay.